So once again, you need to know how to factor before doing section 8.1, which is why we're spending time on it right now. So let's begin with what factoring is. What is factoring? It's simply reverse distributed property. It's when you have the answer and you want the multiplication question, right? So for example, let's take it to something super basic. If I said factor the number 6, or give me two factors of the number 6. 3 times 2, right? So 6 is the answer, and 3 times 2 is the multiplication question, right? So when I ask you to factor something, it's really like having the answer and you want the multiplication question, all right? So that was too basic. But the very first type of factoring that we learned about was factoring out the GCF, right? What is that? That's when you have something in common in all of your terms of your polynomial. Here's a simple, let's say, binomial. Let's say we had 6x to the 7th minus, let's go with the 18x to the 2nd, all right? So what's in common in both of those terms? There's definitely an x, and that's what you call a common factor, but it's not the greatest common factor. So what you want to do is pull out the greatest common factor, the GCF, and let's begin with the number 6 and the number 18. Like, yes, you could pull out the multiple of 2, but that, again, that's not the greatest, right? What is the greatest multiple, the greatest factor of 6 and 18? 6, right? So we for sure are going to pull out the greatest number 6 from both the 6 and the 18. Now, we also said that there's x's in common, but what's the greatest amount of x's that I could pull out of both at the same time? 2 of them, right? So 6x squared, that's what we call the GCF. So just a little review, that's the GCF. And how do we do this, factoring out the GCF? You pull it out and see what would be left over on the inside. It's kind of like distributed property. 6x squared times what will get you back to the 6x to the 7th? Anybody? An x to the 5th. You could put a 1 in front of it, but it's not necessary. But the bottom line is 6x squared times x to the 5th will give you the 6x to the 7th. How about over here? 6x squared times what will give us negative 18x squared? Negative 3, and that's it. And voila, we're done. We have factored. Okay? That's a really easy type of factoring. We're supposed to learn that back in Algebra 1, even before that, where you look at whatever's in common and pull that out. And again, you could pull out like a 2 from the 6 and the 18, but that's not the greatest. You could pull out the greatest common factor of 6x squared. All right, so that's one method of factoring, pulling out the GCF. Another method of factoring is when you have a quadratic trinomial when your a value is 1. So whenever you have something like x squared, let's say minus 2x with the minus 8 right here, okay? Any standard form quadratic trinomial, the a is the number in front of the x squared, the b is the middle term number in front of the x, and the c is the constant number at the end without a variable. So whenever your a value is 1, you could jump right in to this format. Put an x right there and an x right there. Now why is that? Because x times x is x squared, okay? So again, just to review the vocab, if I ask you to factor, what I'm asking you is to find the multiplication question that will give you this answer. And whenever you don't have a number out here, you set this up, and then you simply think, what times what is C that if you combine together is B? And I always say make a list, right? Make a list of the multiples of C. Okay, so how could I get negative 8? That could be a negative 1 times 8, a negative 2 times 4, and negative 3. Nope, that's it. That's the only two possible ways of multiplying numbers together is negative 1 times 8 and negative 2 times 4 to get negative 8. That's besides changing signs. Anyway, which pair of numbers, if I combine them, give me the middle value negative 2? Exactly right. Thank you. The negative 2 and 4, when I combine those, that gives me a positive 2, and I know I want a negative 2. So I have the right number, just the wrong sign, which means I have the right numbers, just the wrong signs. So change that to a positive 2 and a negative 4, And you're done. Just put that positive 2 right there, that negative 4 right there, and voila, we have factored. Yay? So factoring quadratic trinomials with the a value of 1 should be ridiculously easy. All you do is think what times what is c, make a list if you have to, that if you combine together is b. You guys want to try one on your own? Go for it. You have x squared minus 9x plus 20. What would the factored form of that actually be? So you want it to look like this, obviously, and of course you're going to have the x's, but you need to tell me what's going to be here and here. So I know that we already have the answer, but let's walk through this, all right? So again, we're going to think of the multiples of c. I'm going to make a list. How could I get 20? I always start with 1. 1 times 20. And then I go 2. 2 times what? 2 times 10. How about 3? 3 doesn't work. How about 4? 4 times 5. And that's it. Just go through your numbers, 1, 2, 3, 4, 5, and think of what they could be multiplied by to get that c value. Now, out of those pairs of numbers, which combines together to give us the negative 9? Well, if I add 1 and 20, that's 21. That's not good. That's not negative 9. 2 and 10, that's 12. That's not negative 9. 4 and 5, that's 9. But it's still not negative 9, but it is 9. So I have the right numbers, just the wrong signs. So all we got to do is change both of them to negative, and then we'll have our numbers that we plug in right here, a negative 4 and a negative 5. It doesn't matter the order. That's your factored form answer. I hope we understand. Yay? Okay. Now, what if I told you to factor that? You should go through these motions, right? Parenthesis, parenthesis, x, x. Why? Because there's no number in the front. If there's a number, we got to use a different method, which I'll go over in a little bit. But right now, we want to think of the multiples of the c value, which is positive 10, that combine together to give us a b value, negative 3. So how could we get positive 10? That's 1 times 10. That's 2 times 5. And that's it. Now, which of those pair of numbers combines together to give us a negative 3? The answer is none of them, right? I mean, if I actually added 1 plus 10, what do I get? 11. Is that 11 right there? No. Cancel it. How about that? 2 plus 5, what do I get? 7. Is that 7 right there? No. So it's simply not factorable. Not factorable. What does not factorable mean? That you're not able to factor it. You're just simply not able to factor it. It's like me saying, like, rewrite 7 as a multiplication of two numbers besides the number 1 and 7. You just can't do it, right? It's not factorable. You can't break it down. Okay, now, so we also might have a combination of the two, of pulling out a GCF and then still having a quadratic trinomial with the 1 on the inside. Let me show you an example of that. Go with, everybody jot down 5x to the second minus 5x. Let's go with the minus 30, okay? So first type of factoring that you learned, and the first type of factoring you're always supposed to try, is pulling out that GCF. So what is a GCF here? Is there an x in all three terms? No. So what could I pull out? 5, the multiple of 5. If I pull out the multiple of 5, what's going to be left on the inside of the parenthesis? X squared minus x minus 6, right? Now, some of us are going to think, hey, we factored out the GCF of 5, we're done. We're not. Always look at the inside and see if you could continue factoring. And as you can see, right here we have a blue quadratic trinomial with the a value of 1. Up here, the a value is 5. Now right here, the a value is 1. So I could maybe continue to factor with the x right here and the x right there. And again, I'm going to think what times what is my c value, negative 6, that if I combine together is my b value, which is negative 1. I want to make a list over here, negative 1 times 6, negative 2 times 3, and that's about it. So which pair of numbers is going to belong in here? The 2 and the 3, but change the signs, because negative 2 plus 3 is positive 1, and we know we want a negative 1. So we have the right numbers, just the wrong signs. So let's make this a positive 2 and a negative 3, positive 2, negative 3. What about the original 5 that we pulled out from all three terms? That still has to be out there, just bring it down. That's what we call completely factoring. Cool? So we have factoring out the GCF, which we did. We have factoring a quadratic trinomial, which we did. Sometimes it's not factorable. You just write not factorable. And then we have a combination of the two where we pull out the GCF and then we factor the quadratic trinomial. So this leads us to our next type of factoring. So on this one, we have a quadratic trinomial, and you got to try pulling out the GCF, but there's no GCF to pull out. There's nothing in common. You could pull out a 3 from here and there, but you can't pull out a 3 from the middle. You could pull out an x from here and here, but you can't pull out an x from the last one. So there is no GCF. You cannot set this up. Don't do it because you can't do it. Right? That's wrong. Because x times x is not 12x squared. It might be a 12 right here and a 1 right there. It might be a 1 and a 12. It might be a 3 and a 4 or a 4 and a 3. Who knows? So it gets complicated. Anyway, so what are we supposed to do when we have a number out here? A long time ago, I showed you guys this multi-step process on factoring quadratic trinomials when your a value is not 1. Does anybody remember step 1? Yes, multiply a times c, right? Remember, a is 12, c is negative 3. So what is a times c? It's 12 times negative 3. What's the answer? Negative 36, okay. And now step 2, and I want you guys to jot down some notes, and especially if you don't remember. Step 2 is to make a list of multiples of this guy, right? Let's do a list of multiples of negative 36. So I'm going to start with negative 1. Negative 1 times 36. Negative 2 times what? 18. Negative 3 times, anybody? 12. How about negative 4? Will negative 4 work? Negative 4 times 9. Negative 5 doesn't work. Negative 6. Will negative 6 work? Yep, there you go. So you see, I just went through counting 1, 2, 3, 4, 5, and I thought of the multiplication to get the answer, negative 36. And I got all the possible multiples right there, okay? So just like before, which of these pairs of numbers combines together to give us the middle value, positive 5? Negative 4 and 9, right? And we don't have to change any signs. That's ready to go. Negative 4 plus 9 really is positive 5. So this is the correct pair of numbers that we want. Now, the first method of factoring this a long time ago was to change your trinomial to a 4-term polynomial by taking these two numbers and replacing the middle value 5x and replacing it with a negative 4x and a positive 9x that come from here. That way you could have 4 terms, that way you could split them and factor by grouping, which is another 3 or 4 steps on its own. So I'm not going to go that route because after learning factoring by grouping and after showing you that, there was a quicker method, this other method, and I'm just going to stick with that shortcut method. Step 3, in case you forgot, step 3 is to set up this answer format, parenthesis, 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 ax, ax, and then number here and number there. That's how we're going to set it up. I know that sounds weird, but we know that our answers are going to look like two binomials being multiplied together when you have a trinomial like this, right? Now, what is ax in this case? What is a? 12. So I'm going to write a 12x right here and a 12x right there. Now, how about these numbers? Where do you think I'm going to get these numbers from? From the negative 4 and the positive 9. So let's put negative 4, positive 9. Let's do that. Negative 4, positive 9. And it looks like that could be the answer, but it's not, because when I distribute 12x times 12x, I'll get 144x squared, not 12x squared. So we know that this is not completely right. I need to do the 4th and final step. So if you don't remember, write this down. I call it the magically divide each binomial by whatever you can. So take a look at that first binomial, 12 and 4. What could you divide by? You could divide by 2, but what's the bigger value? 4, right? So, I mean, I don't even usually show this, but I'm going to put a divided by 4 just so you guys don't get lost. 12 divided by 4 is 3, and of course with an x. 4 divided by 4 is 1, and there's a minus sign. So your new first binomial is 3x minus 1. What could I divide this second binomial by? I could divide both of them by 3. So if I divide both of them by 3, that's going to give me my second binomial. What's that going to be? 4x plus 3. And believe it or not, guys, this is your factored form right here. So this is the shortcut on factoring a quadratic trinomial when your a value is not 1. It's really easy when your a value is 1. You just think, what times would I see that if you add together is b? But if you actually have a number out here, you got to go through this 4-step process. But in reality, it's pretty easy. Step 1, multiply a times c, get a number. Step 2, make a list of the multiples of this number. There it is, there's my list. See which pair gives you the middle value b. And then the third step is to set this up. Take those numbers, put them right there where the number symbols are at. The ax, simply your a value with x, 12x on both of them. Step 4, magically divide each binomial by whatever you can, and you get to your final answer. Now, if you wanted to double check and see if you actually factored it right, you could distribute 3x times 4x, 3x times 3, distribute -1 times 4x, -1 times 3, combine like terms, and you should get back to that original quadratic trinomial that we started with. Yay, nay, or what the hey? Yay, I hope. Okay, now, when do we do this multi-step process? When your a value is not 1. However, check this out. What if I had 4x squared plus 12x plus 9? Yeah, there's that other factoring method that hopefully, I know some people do remember, but if you don't, if you have a perfect square term in the first term and a perfect square term in the last term, you could take the square roots and plug them right into your answer, all right? So, but of course, double check, right? Because it might not be factorable. But right here, you see I got a perfect square term, and over here I got a perfect square term. So I'm gonna jump right into my answer. The square root of 4x squared is 2x. The square root of 9 is 3. And of course, you want it to be a positive 9 when you multiply this 3 times that 3. So they're either both going to be positives or they're both going to be negatives. Based on this middle term, what do you think? Are they both positives or are they both negatives? Both positives, because the middle term is positive. Now, if that would have been a negative, I would have guessed that both of them are negative and then double checked it, right? But because it's positive, both positives, and that's it, we're done. Of course, double check your answer. I'm just going to do it in my head real quick. 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is another 6x. So both of those 6x's added together, it'll give us that middle term 12x when I combine like terms. And then 3 times 3 is 9. So I know I did it right. Cool? And it's even easier if you have a difference of two squares. Like, for example, if I told you, what if I had 36x to the second minus 25? That's really easy to factor because you have perfect square terms in the front and in the back, and there is no middle term, which means that the middle terms have to cancel out, which means that one sign is going to be positive, one's going to be negative. Either way, what's my answer going to be? I guess I shouldn't have said either way, but what's my answer going to be right there? What's the square root of?
6 plus 5 and then 6x minus 5.
Yep, the square root of this guy is 6x, and the square root of this guy is 5. And of course, if you want it to be a negative 25 at the end, this has to be a positive 5, and this has to be a negative 5. Or the other way around, a negative 5 and a positive 5. Either way, they have to be different, the signs. And there's your answer, okay? Keep in mind that some quadratic trinomials, some polynomials are not factorable. But those are all the different types of factoring that we need to be really, really good at. Not just know how to not understand what I did right now, but really good at on your own factoring, okay? If you're not good at factoring, there's no way you're going to pass section 8.1 that we're going to start tomorrow. So I highly recommend you guys practice. And how are we going to practice? I did a quizzes assignment for you guys. It's going to actually go into your homework as a homework grade, into your grade as a homework grade. So it's only, I think, 15 questions long, and it has all these different types of factoring that we worked on right now.